Hi folks, today I bring a VFD and a driver that is in itself a complete clock. The technical specification of the IC define it as a car clock. The IC is powered by the plus 5 volts DC. It has an enable pin that in this clock also serves to activate the filament power circuit. The total power supply to the circuit in this case of a vehicle clock is natural plus 12 volts DC. The method used to create the integrated circuit's power supply requires some attention in its analysis, as it can easily induce in errors. So, I draw attention to the fact that, as I mentioned, the power supply for the entire circuit is the plus 12 volts DC, but the IC is plus 5 volts DC. I would like to emphasize the details that the IC's VDD is connected to the plus 12 volts DC, and therefore requires the creation of an intermediate voltage point, which in this case is plus 12 volts DC minus the plus 5 volts of the IC, which result in the plus 7 volts DC in relation to the GND. This method results in a negative voltage with respect to the VSS. Our intermediate plus 7 volts is the 0 volts of our 5 volts DC to power up our IC. The IC has 3 pins for the buttons that allow you to adjust the minutes, hours, and reset the minutes. Brightness can be set by the stats of the DS1 and the DS2 pins. There are 3 test pins, T1, T2, and the T3, which held in low states. The VFD has a single grid, so all segments present in display have an individual output from the IC except for the segments B and C of the digit 1 in the left, where both come out from the pin 4 of the IC, marked as a BC4. For those who had contact with the LM8361 that use a LED display, also use this method to control the segments of the first digit of the LED displays. The time base of the clock is done with a crystal of the 4194304. I don't know which models of the cars make use of this clock. If someone knows, please let it in comments. The draw of the PCB let the clock very compact to the epoch.